This is an assembly of our medical skin stapler, and I'll be explaining how we created it. Now, all of the 40 parts in this assembly were hand created or pulled from Toolbox, with the exception of these bolts, which we got from McMaster, and we had to do that simply because we couldn't find the right length of screw in Toolbox. For sake of time, I'll be explaining the general logic behind a lot of these mates instead of going through every single mate. As there's 40 different parts, there wouldn't be enough time. Now, whenever there were two faces that we had to mate together, for instance, like this face on the shell and the back face of the front plate that I just hid, we used coincident mates, and this ensured that the two faces would be in the same plane at all times. In addition, we often created coincident mates between edges to fully define parts, for instance, this front plate to this shell. It's important to note that the shell is the base part, and it shares an origin between the assembly and the base part, so all other components inserted afterwards can be fully defined around this base part. Now, whenever there were circular parts that we had to deal with, like the screw, we often used coincident mates to do so, or to insert the parts. For instance, we created a coincident mate here between this edge and between this edge, and this ensures that the two circles stay in line with each other. Now, other mates had to be used in addition to these concentric mates to fully define the screws and other parts that use coincident mates, but they do play a key part in our assembly. It's important to note that a lot of these concentric mates had to have their rotation lock to make sure that the assembly is fully defined, as shown. We also used width mates a good amount throughout this assembly. You can see one here. When we inserted this piston slide, we created a width mate between this face on the shell and this face on the front plate, and this ensures that this part would be centered in between these two faces. Now again, there were other mates that had to be used, but that's just one of the ones that was used on this piston slide here. There is also a width mate used on the trigger, and this was nice because the trigger is slightly smaller than it needs to be to perfectly fit in between here, and that's because when 3D printing we had to account for tolerances, hence why we used a width mate instead of a coincident mate. There's an angle mate between this edge and this edge on the trigger, and this was simply to fully define the assembly. However, this mate can be suppressed to show full range of motion. And lastly, there was a profile center mate used between the spring here and the bottom of this cartridge, and this ensured that these two parts would be fully defined, and it's important to note that a rotation lock was also used when mating this base to the spring.